Okay, folks, L'Hopital's rule. This will be assignment number 40. So this is it. We're going to do 9 examples using this rule. And I've always thought L'Hopital sounded like a medication. So that's the thing you'll hear on this. Just very quickly, L'Hopital was a French mathematician, Guillaume de L'Hopital, and there he is. And he's the person who is credited with developing this rule. And again, it's a very involved proof as to why this rule works. But the first thing would be, this is going to be example number 1. And you see it on the board as well as the screen, just so you have context here. And these again are the examples and notes that were uploaded to you. So here's the thing, L'Hopital's rule, before you prescribe L'Hopital to a patient, you need to check to see if your limit is what's called indeterminate. All right? You have to be indeterminate before we prescribe L'Hopital. And in order to be indeterminate, you're either going to be 0 over 0 or infinity over infinity. Those are considered what are called indeterminate forms in calculus. So, what we would do is we would substitute the 1 in for x. Obviously, 1 squared minus 1 would be 0 down here. Now, in the past, we used to say, if substitution leads to division by 0, then we have to use a technique to do this. And in fact, we did this one earlier where we factored it and canceled. And it worked back in the day. But if we're going to investigate L'Hopital's rule, so again, we put 1 in for x here, we get a 0. If we got anything other than 0, then cool, we're good to go. But if that denominator is 0, then I would say, what happens in the numerator? Well, 1 minus 1 is also 0. So we would say, yes, this particular limit is indeterminate, 0 over 0. Let's prescribe some L'Hopital for this patient. L'Hopital's rule then goes on to say that if your limit is indeterminate, either 0 over 0 or infinity over infinity, then your original limit, the limit as x approaches c, f of x over g of x. Notice this basically says to take the derivatives of your numerator and denominator individually. So you take the derivative of your numerator, which is 1. You take the derivative of your denominator, which is 2x. Notice you take the individual derivatives. What I often tell people is this is not to be confused with the quotient rule. You just take the derivative. Let's backtrack. Make sure it's indeterminate first. If it is, you prescribe L'Hopital. And you take the derivative of the numerator, you take the derivative of the denominator, and then you see if your new limit is something you can evaluate. Going back to substitution, if you put 1 in for x, this will equal 1 over 2 times 1, a half. That's it. So 1 dose of L'Hopital cured the patient, and wow.
That was easy.
But again, it needs to be emphasized that it needs to be indeterminate before you can apply the rule. And some of the limits that we enjoyed in the past were not indeterminate at the beginning. But anyway, like I said, make sure the patient's indeterminate, and if they are, prescribe L'Hopital and hope that it cures them. So, L'Hopital. For those times when you're indeterminate, L'Hopital.